Okay, today we're going to look at section 4.2. We're going to talk about exponential functions. An exponential function. If a is a positive real number and a is not equal to 1, then the function f of x equals a to the x is an exponential function with base a. Which of the following functions are exponential? This one is no. No. This one. Here I have no exponent. This one is no, because note the exponent, a is a constant, the exponent is a variable. So this one is yes. Okay. Same here. We have more to deal with here. So no. Here we have a constant to some exponential power. So this is yes. Again, here we have a constant to some exponential power. So yes. So let's evaluate some functions. We have f of x equals 3 to the negative 2x. So find f of 1. Well, this is simply 3 to the negative 2 times 1, which is 3 to the negative 2, which is 1 over 3 squared, which is 1/9. Remember, the negative exponent means to flip it. Here we have f of 0, so I have 3 to the negative 2 times 0, which is 3 to the 0, and anything to the 0 power is simply 1. Okay, so f of 2 here is equal to e to the 2 squared plus 5 times 2, which is e to the 4 plus 10, e to the 14th. If you want to use your calculator, you can use that to find out an estimate, but I don't really see the point in it. But if you're interested, e to the 14th is 1202604.284 according to my calculator. But again, unless it says to do it, I wouldn't do it. This is a precise answer. This is an estimate. Okay, so now we have f of negative 1. So I have e to the negative 1 squared plus 5 times negative 1, which is e to the 1 minus 5, which is e to the negative 4, which would be 1 over e to the 4. And this comes out to be 0.018315639. Again, this would be the answer that is more precise. So let's look at the graphs of exponential functions. An exponential function in the form f of x equals b to the x, where b is greater than 0 and b does not equal 1, has these characteristics. First of all, it's a one-to-one function. Secondly, it has a horizontal asymptote at y equals 0. The domain, the x values, are negative infinity to infinity. The range, since it has that asymptote at y equals 0, is from 0 to infinity. It does not cross the x-axis. It crosses the y-axis at 0, 1. For b greater than 1, it's increasing. That's here. For b less than 1, it's decreasing. That's here. So For any constant c and d, the function f of x equals b to the x plus c plus d shifts the parent function f of x equals b to the x vertically d units in the same direction of the sign of d, horizontally c units in the opposite direction of the sign c. This is just like what we did before. The y-intercept becomes 0, b to the c plus d. The horizontal asymptote becomes y equals d. The range becomes d infinity, and the domain negative infinity to infinity remains unchanged. Find the horizontal asymptote, the domain, the range, and the y-intercept. Then plot a few more points to graph the function. So what do we have here? This one's a basic function. So there's no shifts at all in this one. It's simply f of x equals 4 to the x. So what do we graph? Find the horizontal asymptote. Well, the horizontal asymptote is here at y equals 0. The domain is going to be negative infinity to infinity always. The range, 0 to infinity. Our y-intercept will be standard y-intercept is 0, 1, which is right here. So we're looking at this. Okay. So here we have f of x equals 3 to the negative 2x. So what are we looking at? We're looking at again, we're not adding units, we're multiplying units. So here, the only thing that's going to change is our graph itself. So let's see. Again, our horizontal asymptote will be the same. Our y-intercept, well, y equals 0. Our y-intercept, when x is 0, this is simply 1 again. Standard form. Our range will be negative infinity to infinity still. Yep, that's backwards. Our range is 0 to infinity. Our domain is negative infinity to infinity. Now, if we graph some more points, what happens if I let let's do x, let x equal negative 1. If x equals negative 1, I get 3 to the negative 2 times negative 1, 3 squared, which is 9. So I'm looking at a point here. If x is positive 1, get 3 to the negative 2 times 1, which is 3 to the negative 2, which is 1/9. So we got the same thing, same basic shape, but it's squished together. All right, so now we have our shifts. So when we add, let's look. We're going to shift vertically d units and opposite direction c, horizontally. So here we're going to shift vertically -3 and horizontally -2. So that means my asymptote is at -3. All right, shifting down vertically, -3. Y equals -3 is my asymptote, which means my range will be -3 to infinity. My domain will always be the same, -infinity to infinity. What about my x-intercept or my y-intercept? Okay, opposite direction. So we have +2, so I'm going this way. So let's just find out what happens when x is 0. We have 2, the 0 plus 2 minus 3, which is 2 squared minus 3, which is 4 minus 1 minus 3, which is 1. Okay, move left 3, or left 2 down 3, and then I have enough here to drop. Okay, now we're looking at e to the x. Do I have a graph? Yes, I do. So all I'm doing here is going left 1 unit. So on my graph, my asymptote is y equals 0. Moving everything left 1 unit. So that's here, there, and it's going to look roughly like this. Okay. So my range is 0 to infinity, domain, -infinity to infinity. Let me write that a little neater. My y-intercept, when x is 0, I get e to the 0 plus 1, which is e. So my x-intercept is 0e, which again, we can just leave imprecise. We don't need to come up with a number. What else were we looking for here? Intercept, domain, range, graph. And I believe that's it. Okay. So we can look at exponential equations in a different fashion too. We have a property of exponents. If a to the b power is equal to a to the c power, then b equals c. So here I have 6 to the -2x equals 4. That means that -2x equals 4. We divide by -2 and we get x equals -2. This one's a little difficult. Okay, I have a base of 5. Well, this is 5 squared. I have 5 to the 2x plus 1 equals 5 squared, which means that 2x plus 1 equals 2. 2x equals 1, x equals 1/2. Okay, this one's a little more difficult to look at. 32 is equal to 2 to the what? fifth. And 16 is equal to 2 to the fourth. So I have 2 to the fifth to the x plus 1 equals 16 to the fourth to the x minus, or 1 minus x. So when we have exponents to exponents, we just multiply the exponents at 16. 2. So essentially what we're saying is 5 times x to the first is equal to 4 times 1 minus x. So I have 5x plus 1 equal to 4 minus 4x. Add 4x to both sides, I get 9x. Subtract 1 equals 3. X equals 1/3. Okay, so I have e to the x minus 1 equals 1 over e to the fourth is simply e to the negative fourth, then multiplied times x plus 1. So this is telling me that x minus 1 equal to negative 4 times x plus 1. So x minus 1 is equal to negative 4x minus 4. Add 4x to both sides, I get 5x. Add 1 to both sides equals 3. So x equals 3/5. And I believe that is it. Okay, so that finishes up this section. Remember, if you have any questions, feel free to email me. I can set up a private Zoom. If you have time and are able to, come to the regularly scheduled Zoom meetings on Monday and Wednesdays. I can try to answer questions via email. I'll work with you any way we can to get any questions you have answered. That's all for this time. I will see you next time.